Sarah, are you online? Okay, I'm still waiting for my students. Sarah, are you here now? Okay. Can you see me now?
Okay. Yes, sir.
All right. So let's begin. Okay. Good evening, Sarah, and welcome to today's class. If you can see me, kindly identify or acknowledge this message on the comment section. Just tell me I'm here. I can see somebody's online. Sarah, is that you? Can you hear me? Am I audible enough? Sarah, I'm waiting for your response at the comment section. Sarah, are you with me? Just type yes, I'm here. Sarah, I've not seen your response, so I'm going to wait for you. Sarah, are you online? Can you reply me at the comment section?
Hello, sir.
Are you sure you're online?
Yes, sir.
So why are you not
5
responding?
seconds late, something went wrong. So my text, you're not be able to see it until after 5 seconds or something like that.
Is that what they said on the vacancy?
No, like I don't know, my hand slipped and it went 5 seconds backward.
Okay. All right. So let me begin the class.
Yeah.
I'm going to put this on so as not to dirty my tablet. This is a glove that came with my printer. Okay. Sarah and viewers out there, good evening and welcome to today's class. Today's class is a continuation of our previous classes on GSS2 mathematics. If you could remember, we started this term with whole numbers, and under the whole numbers, we have been able to look at whole numbers in standard forms as well as decimal numbers in standard forms. We have been able to touch these two subtopics under whole numbers. We equally looked at the basic laws of indices, and we're able to solve some exercises. So in today's class, we shall be looking at the third subtopic, which is on prime factors and prime factorization. We shall take these two together. So just like I said, in today's class, we shall be looking at factors and prime factorization. I believe you must have done this in your junior secondary 1, but this is going to be like a revision for us to move further. You won't be forced to ask his or herself, what do you understand by prime factors? But before you look at prime factors, let's break it into two. What are even factors? Okay, so when you know the definition of factors, you can then talk about prime factors and how to factorize. All right. Now I said under definition that a factor is a number that leaves no remainder when it is used to divide another whole number. For example, 1, 3, 5, and 15 are factors of 15. Another way you can define a factor as a smaller number that divides a bigger number without a remainder. Factors are always equal to or less than a whole number. And I give an example that 1, 3, 5, and 15 are factors of 15. Why are they said to be factors of 15? They are called factors of 15 because they can divide 15 without a remainder. 1 can divide 15 times without a remainder. 3 can divide 15 5 times without a remainder. 5 can divide 15 3 times without a remainder. And 15 can divide 15 once without a remainder. So they are said to be factors of 15. 2 is not a factor of 15 because 2 cannot divide 15 without a remainder. Or dividing 15 into 2 gives you 7 remainder 1. So when you divide a number by a smaller number and you end up having a fraction or a decimal, such numbers are said to be non-factors of that number. So once again, I said factors are smaller numbers that can divide a bigger number without a remainder. What about prime factors? Now that we have known what factors are, what are prime factors? A prime factor is a number that has only one and itself as factors. For example, 2, 3, 7, 17, and 23 are prime numbers. Now, I said a prime number is a number that has only 2 factors, 1 and itself. What that means is any number that can only be divided by 1 and itself is said to be a prime number. For example, 2 is a prime number. Why is 2 said to be a prime number? 2 is said to be a prime number because there are only 2 numbers that can divide 2 without a remainder, and that is 1 and 2. When you divide 2 by 3, it gives you a fraction. When you divide 2 by 4, it gives you a fraction, and so on and so forth. So since 2 has only 2 factors, or 2 numbers that can divide it without a remainder, we refer to 2 as a prime number. What about 3? 3 is also a prime number because only 1 and 3 can divide 3 without a remainder. If you should divide 3 by 2, you are going to have 1 remainder 1. So 2 is not a factor of 3. What about 4? 4 is not a prime number because 4 can be divided by 1, 2, and 4. So it has not fulfilled the condition for it to be a prime number, of which we say a prime number is a number that has only 2 factors, 1 and itself. So 4 is not a prime number, but 2, 3, 5, 7, 11, 13, etc. They are said to be prime numbers. 1 is not a prime number. Why is 1 not a prime number? 1 is not a prime number because 1 has only 1 factor, and that is 1 itself. While others I have mentioned have 2 factors. So a prime factor is a prime number is a number that has only two factors, 1 and itself. Or we say a prime number is a number that has only 1 and itself as its factor. What about a prime factor? A prime factor is a factor that is a prime number. A prime factor is a factor that is a prime number. For example, 2 and 5 are the prime factors of 20. They are the prime factors of 20 doesn't mean they are the only prime numbers that we have. Prime factors must be associated with a number. For example, I say 2 and 5 are the prime factors of 20. This is because 2 and 5 are the only numbers that can divide 20 without a remainder and has only two factors that can divide them themselves, which is 1 and then themselves. So we can always write every non-prime number as a product of prime factors. I'll come again. We can always write every non-prime number as a product of prime factors. Yes. Example, 4 can be written as 2 times 2. 2 is a prime number and a prime factor of 4. 6 is not a prime number. So we refer to it as a non-prime number, and 6 can be written as a product of its prime factors. What are the prime factors of 6? All you need to do is to, first of all, identify those numbers that can divide 6 or those factors of 6, and thereafter check amongst them which have only 2 factors. Those are said to be prime factors of 6. So let's take an activity. In this activity, we should be able to tell how we should be able to write out the prime factors that falls between 1 to 200. I think we should also look at the objective of this class. Remember, I gave you the objective that we should be able to, okay, we have done this objective, we should be able to find the prime factors of numbers not greater than 200. So we shall look for all the prime factors that falls between 1 and 200. And we should be able to express numbers as product of their prime factors. So back to the class. So activity 1.1, for us to be able to determine the prime factors between 1 and 200, we are going to shade all the non-prime numbers by following these steps. What we are going to do, we are going to list out all the prime factors, all the numbers from 1 to 200, and then be able to identify all those that are prime numbers. Just give me a minute, I'll be back. Okay. Sorry for that break in transmission. We can now go ahead with our class. So, in this activity, I said we should shade all the non-prime numbers by following these steps. One, shade all the multiples of 2. So we are going to shade all the multiples of 2, shade all the multiples of 3 at step 2. Step 3, we are going to shade all the multiples of 5, shade all the multiples of 7, shade all the multiples of 13. So, I've been able to take my time to write out all the numbers from 1 to 200. So we are going to do as was said. Okay? So the first step is to shade all the multiples of 2. But in this case, I'm going to circle all the multiples of 2. So multiples of 2 between 1 and 200, we have 2, 4, 6, 8, 10, 12. Multiples of 2, you can start from 2 and be circling every 2 numbers you have after 2 is equivalent to you shading or circling the multiples of 2. So we have 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, 52, 54, 56, 58, 60, 62, 64, 66, 68, 70. Now, if you look at it, you will agree with me that it's following a particular pattern. Okay? So, I can therefore do, okay, let's just go ahead by circling them. What I'm doing is we are trying to identify all the prime numbers that falls between 1 and 200. So this is 102, 104, 106, 108, 110, 112, 114, 116, 118, 120, this, 134, 136, 138, 140, 142, 144, 146, 148, 150, 152, 154, 156, 158, 160, 162, 64, 66, 68, 70, 72, 74, 76, 78, 80, 82, 84, 86, 88, 190, 192, 194, 196, 198, 200. So we have taken the first step in trying to write out all the prime factors. Okay? So the first step says shade all the multiples of 2. That we have done. The next step is shade all the multiples of 3. So multiples of 3, beginning from 3, we have this 3, 6 has already been shaded 9, 12, 15, 1, 2, 3, 18, 1, 2, 3, 21, 1, 2, 3, 24, 1, 2, 3, 27, 1, 2, 3, 30. Okay, just be skipping every 3. We have 33, 36, 39, 42, 45, 48, 51, 54, just be adding 3, 57, 60, 63, 66, 69, 72, 75, 78, 81, 84, 87, 90, 93, 96, 99, 102, 105, 108, 112, 112, 115, 118, 121. Is it a multiple of 3? I have missed it somewhere. Is 121 a multiple of 3? No. I have 109, 112, 1, 2, 3, okay, 115, 1, 2, 3, 118. Is 112 a multiple? Okay, I stopped at 99. 99 plus 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, it's 108. It is not 109. So 109 is not. So this is 109 and 119. So 108, 1, 2, 3 is 111. 1, 2, 3. So it's not 115. 115 is not. So it's 114. 114 plus 3 is 117. Now, for you to know the multiples of 3, if you add up all the digits in that number, it should be able to give you a number that is divisible by 3. For example, 119. If you add up 1 plus 1 plus 7, it gives you 9, and 9 is a multiple of 3. So that's how you can know if a number is a multiple of 3. So 117, 120, 117, 120, 123, 123, 123, 126, 123, 123, 123 is 135. Okay, yes, but it is a multiple of 3. 138, 1, 2, 3, 141, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 165, yes, 1, 2, 3, 1, 2, 3, 171, yes, because this is 9. 1, 2, 3, yes, 1, 2, 3, yes, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so these are all the numbers that are multiples of 3. What we are trying to do is to write out all the prime factors that falls between 1 and 200. So I'm showing you how you can generate all these numbers without making a mistake, and you arrange them in ascending order. The next step, we have looked at this, we have looked at step 2, is to shade all the multiples of 5. Just like I said, you now count in 5 beginning from 5. So we have 5, 10, 15, 20, 25, 30, 35, 40, 45, 50 have been shaded, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100, we go to 105, 110, 115, 120, 125, 130, 135, 140, 145, 150, 155, 160, 165, 170, 175, 180, 85, 190, I've been shaded, 195, and then 200. So we have just completed the third step in achieving that, which is to shade the multiples of 5. Step 4 says we should shade all the multiples of 7. Do same to multiples of 7, 11, and 13. So 7 is we have 7, 14, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 42. Where I stopped. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. The next one should be 77. We have 84. 84 plus 7. 1, 2, 3, 4, 5, 6, 7. That's 91. 1, 2, 3, 4, 5, 6, 7. 98. 1, 2, 3, 4, 5, 6, 7. 105. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 140. 1, 2, 3, 4, 5, 6, 7. Shaded already. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 182. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so we have shaded all the multiples of 7. Now, shade all the multiples of 11. Multiples of 11, you have 11. 11 plus 11 is 22. 22 plus 11 is 33. 33 plus 11 is 44. Okay, in that order: 44, 55, 66, 77, 88, 99. 99 plus 11 give you 110. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, plus 11. When you add 11 to this, give you 121. 121 is shaded. 121 plus 11 will give you 132. 132 plus 11 will give you 142. 142 plus 11, if you look at it, they are even arranged, is 152, 164, 175. 175 plus 11 is 186, and we have 197. So we have shaded all the multiples of 11. And now shade all the multiples of 13. All the multiples of 13 include 13. 13 plus 13 is 26. 26 has been shaded. Plus 13 is 39. 39 has been shaded. 39 plus 13, this will give us 52. 52 has been shaded. 52 plus 13, that is 65, has been shaded. 65 plus 13, 65 plus 13, that will be 78. It has been shaded. 78 plus 13, that will be 91. It has been shaded. 91 plus 13, 104. That has been shaded. 104 plus 13 is 117. That has been shaded. 117 plus 13, 130. That has been shaded. 130 plus 13, that will be 143. It has been shaded. 143 plus 13, that will be 156. It has been shaded. 156 plus 13, that will be 168. It has been shaded. 168 plus 13 is 181. Yes, that will be 181, not shaded. 181 plus 13, that will be greater than 200, but we have to stop at 200. Okay, so we have been able to shade all the multiples of 13. Now, what is left? I said all the unshaded numbers are the prime numbers of 1 to 200. All the unshaded numbers. So let's write them out. All those that were unshaded, we have 1. I'm going to write them out. So I have 1, 1, 17, 19, 17, 19, 23, 23, 29, 'Now remember, because we have used 2, 3, 5, 7, 9, and 11, we are also going to write them, okay? They are also prime numbers, simply because I said we should take all the multiples of that, okay? So they are the prime numbers that we know already. So therefore, between 1 and 11, and I've already mentioned that 1 is not a prime number because it has only 2 factors, 1 and itself. So we only consider numbers from 2 and above. Okay, 1 is not a prime number. So I'm going to remove it from the list. Let me rewrite all those we have divided already. We have 2. Remember, I said 2. Why am I using this? 2, 3, 5, 7, 11, 13. Then we have 17, 19. After 19 is 23 and 29. 23 and 29. We have 31 and 37. 31 and 37. We equally have 41. 41 and 47. 41, 47. We move to the next column, which is 53 and 59. 53 and 59. We equally have 61 and 67. 61, 67. Next is 71, 71, 73, and 79. 71, 73, and 79. Next is 83 and 89. 83, 89. 97 and 101. 97, 101. We equally have 103, 107. 103, 107. 109 and 113, 109 and 113. We also look at 127 and 131, 127, 131, 137 and 139, 137, 139, 137, 139, 149, 149. After 149, we have 151 and 157. 151, 157. Then we have 163, 167, 169, 163, 167, 169, and 173, 179, 173, 179. Then I have 187, 191, 191, and I think it's 193, 193 and 199, 193 and 199. So these are all the prime numbers that we have between 1 and 200. All these are the prime numbers in ascending order, and this is just the best way you can get them. There's another way you can use in getting all these numbers, but for you to get them without stress or without any mistakes, just follow these 6 steps which I just gave, and they are the steps includes 1, to shade all the multiples of 2, 3, 5, 7, 11, and 13. So all the unshaded numbers are the prime numbers from 1 to 200. So I now ask this question: why is it not necessary to shade the multiples of 4, 6, 8, 9, and 10? Why must it be multiples of 2, 3, 5, 7, 11, and 13? Why not 4, 6, 8, 9, and 10? We have already established that these are not prime numbers. So you shading their multiples will not give you the prime numbers. Once you shade their multiples, then you will not get the prime numbers. That was why we didn't shade the multiples of this. Okay, if that is that, why is it not necessary to go beyond step 6? In the sense that I shaded up to step 6, which says shade all the multiples of 13. Why not include 17, 19, and the rest? Now, if you look at the multiples of 19, or 17, I think it has already been shaded by the multiples of 2 to 13. Yes, I think so. So if you shade, for example, the multiples of 20 of 17, it will give you 34, and it's the same thing as 17 times 2. So it has already been cancelled by the multiples of 2. Same thing goes with 39, 26, and 23, 29, and so on and so forth. So it will be like a repetition of what you have already done. You will still discover that there will be no new numbers to cancel. For example, let's look at multiples of 17. If you go back to multiples of 17, the multiple of 17 includes, okay, we include 17. 17 plus 17 is 34. And 34 has already been shaded by multiples of 2. Plus, if you add 17 to this again, 34 plus 17 will give you 51. 51 as the next multiple has already been covered by the multiple of 3. So it will just be a waste of time. That was why you don't need to shade multiples of 17, 19, 23, 29, and so on. Now, list out all prime numbers between 1 and 200, and that is what we just did. Kindly like my videos as you watch. While I recommend that you subscribe to my channel if you are yet to do so. Also turn on the notification bell so as to be notified whenever a new video is being uploaded. You can also use the comment section to interact with me on areas that are still difficult for you to understand. You can share the link with your friends and families so that they can also join us in our daily classes. So I shall take reactions from students online. Sarah, can you hear me? Do you understand all what we have done? Sarah, is it clear to you? Let me know in the comment section. Sarah, you have not been responding. I have not been seeing your messages. Okay, you can send it to me on WhatsApp. Can you hear me, Sarah? You understand all I have said? Sarah, if you don't understand what I'm saying, can you like this video? Sarah, I'm still waiting for your reply. Sarah, are you with me? Okay, it means you are following, right? Sarah, you're not responding to my call as a chat. Okay, I can't see that way. Okay. All right, let's go ahead. Okay. Let's take examples. Example 1 says we should express 18 as the product of its prime factors. Expressing 18 as a product of its prime factor, we are going to use the long division method. And in this method, what you are going to do is we are going to divide 18 repeatedly by any of these prime factors that we know. For example, the first one is 2, so we are going to be using 2, 3, 5, 7, 11 to divide 18 repeatedly until we get to 0. So when that is done, you will now tell if you can then see the prime factors that are able to divide 18, and you now express 18 as a product of its prime factor. For example, 2 into 18 is said to be 9 times. Now, I will keep using 9. I'll keep using 2 to divide the multiples until I get to, I'll only stop using 2 when 2 can no longer divide. For example, 2 can no longer divide 9 again. So I'll pick the next prime number. Can it divide 9? If yes, I go ahead. So 2 into 9, it cannot. So I'll pick the next, which is 3. 3 into 9 is 3. Can 3 still divide 3? Yes, so continue. 3 into 3 is 1. And at this point, you stop. So that 18 can now be expressed as a product of its prime factors as 2 times 3 times 3, which is written as 2 times 3 raised to the power of 2 in index form. Now, I have already discussed what we meant by prime factors. I said prime factors are factors of 18 that are prime, meaning factors of 18 that have only 2 factors, 1 and itself. So ordinarily, you can also state the factors of 18. For example, we can state the factors of 18 to include 1. 1 can divide 18 without a remainder. 2 can divide 18 without a remainder. 3 can divide 18 without a remainder. What else can divide 18 without a remainder? 6 can divide 18 without a remainder. 9 can divide 18 without a remainder. And 18 itself can divide 18 without a remainder. So these are the factors of 18. I'm showing you a different method in getting this. When you have listed out all the factors of 18, then look for those factors that are prime. Factors that are prime in here are said to be 2 times 3. But if you look at it, 2 times 3 is 6. If you multiply it by another prime factor, it gives you 9. So you can either use this way to get the prime factors of, to express 18 as the product of its prime factor, or you use the long division method. But the long division method is best in the sense that it makes it easier for you to get. I already know that 2 times 3 is 6 and 6 times 3 is 18. Not all of you will know. So always make use of the long division method. Kindly like my videos as you watch. While I recommend that you subscribe to my channel if you're yet to do so. Also turn on the notification bell so as to be notified whenever a new video is being uploaded. You can also use the comment section to interact with me on areas that are still difficult for you to understand. You can share the links with your friends and families so that they can also benefit from our live classes. So, example 2 We have to express 360 as a product of its prime factors. In this example will equally tell you more as to why you should make use of the long division method as against you finding all the factors of that number before looking for those that are prime. Now, if you have bigger numbers other than 18, it will be very difficult for you to write out all the factors. Most times you will miss one. But I shall also give you a trick on how to get all the prime factors of a particular number. So, for us to express this as a product of its prime factors, we have to use the long division method in dividing. So I'm going to be dividing 360 by all the prime factors, which are 2, 3, 5, 7, 11, 13. Remember, I said we don't make use of 19 and the rest until we have exhausted all of this. So let's start with this. 2 can go into 3. 1 time remainder 1. This becomes 16. 2 into 16 is 8 times remainder 0. 2 into this is 0. So 2 can still divide again because this is divisible by 2. 2 into 1 I cannot. 2 into 19, 18 is 9. Remainder 0. 2 into 0 is 0. 2 can still divide again. So you keep dividing by 2 until 2 can no longer divide. 2 into 90 is 45. But 2 cannot divide 45. So I will go to the next prime number, which is 3. Can 3 divide 45? Yes. 3 into 45. 3 into 4 is 1 remainder 1. This becomes 15. 3 into 15 is 5. Can 3 divide? Yes. 3 into 15 is 5. Can 3 divide 5? No. So I'll pick the next prime number, which is 5. 5 into itself is 1, and that is the end. So that 360 can be expressed as a product of its prime factors as 2 times 2 times 2 times 3 times 3 times 5. So it is a product of all these numbers. And this can be written in index form as 2 raised to the power of 1, 2, 3 times 3 raised to the power of 2 times 5. So this is what you get, expressing 360 as the product of its prime numbers or prime factors. Exercise 2.1. I shall be leaving this for you to solve as an assignment, Esther, Sarah. You shall use, I said, exercise 2.1, using the division table, express the following as product of their prime factors, leaving your answers in index notation. So you have this to do as a take home. So kindly copy out these questions and you will solve and submit in the next class. So please go ahead and copy them. Hello, Sarah. Have you copied out the questions? Okay, so you have to do them and then you submit. Send it to me on WhatsApp, okay?
Okay. Yes, sir.
All right, so we are going to end the class at this point.
Okay, sir.
Good
Good night, sir.
night. Tell Raphael to send the assignment I gave him. That will be for his own class today.
Okay, sir.
Has he done it?
I was having difficulty with you.
Okay. So we are going to look at it tomorrow. Let him just make effort and see. I'll call for a class tomorrow morning.
Okay, sir.
Yes.
Good night, sir.
Good night, Sarah. That brings us to the end of today's class. In today's class, we have been able to look at factors and prime factors, where I told you that factors are said to be smaller numbers that divide a bigger number without a remainder. And prime factors are said to be factors that are prime, or we'll say prime factors are said to be factors that has only two factors, one and itself, of which we say a prime number is said to be those numbers that have only two factors, one and themselves. So if a number which is a prime number happens to be a factor, it can be referred to as a prime factor of that number. Don't forget to like my videos as you watch, while I recommend that you subscribe to my channel if you are yet to do so. Also turn on the notification bell so as to be notified whenever a new video is being uploaded. You can also share the link with your friends and families so that they can benefit from our live classes. You can use the comment section to interact with me on areas that are still difficult for you to understand. Thank you for being part of this class. See you in our next class where we shall look at LCM and HCF. Do have a nice day. Good night.